Hi, folks. Welcome here on Thursday morning. Thank you for being here with us. And welcome to optimize your workloads with Azure Disks and page blobs. So today we have some great content for you. My name is Vaibhava Ramadas, and I'm a program manager in the Azure Storage engineering team. And with me today, we have a great contingent of product managers, including Yumin Liu, Sirius Kutian, and Michael Mara, who are all from the Azure Disks team. So we're very excited to take you through our product portfolio today. So some of the key takeaways that we want you to walk away with today is we announced Ultra SSD in our keynote. So Scott talked about Ultra SSD and how it really stands out in comparison to our competition in the public cloud. And we want you to learn as much as possible about Ultra SSD. Now, we want you to leverage Ultra SSD for all of your mission-critical and latency-sensitive workloads and get started with our private previews. And we'll talk a lot more about that technology. We have a great map that shows you the entire Azure Disk portfolio and how to choose the perfect Azure Disk for your workload. And so we'll take you through a lot of that decision tree and all of the great capabilities of the different Azure Disks in our portfolio. And as well, we have a couple of key great points on our Disks roadmap and what we have upcoming over the next 6 months. So you have visibility into how we're enhancing our platform. Now, this is sort of the overview of the session today. We're going to give you a bit of an overview on Disks itself, take you through what's new and what's come up in the last month or so, and then take you through how to choose the right disk for your workload, as well as take you through everything that's coming up that's new on the roadmap. Now, Azure Disks are the persistent, performant block storage that sits behind and powers the Azure IaaS VMs. Our Azure Disks comes in a couple of different flavors. We have standard HDD, which is backed by magnetic drives, and that is a low-cost solution for you to do dev task workloads. And then we have our SSD family, all the way from standard SSD to Ultra SSD, which got released just this week on Monday. Standard SSD is fantastic for low IOPS workloads like web servers, and is a great way for you to get started for your entry-level production workloads. We have Premium SSD, which is the default recommended way for you to deploy databases and IO-intensive workloads in production on Azure. And then we have Ultra SSD now, which offers extremely low latencies, sub-millisecond latencies with very high IOPS for your extremely latency-sensitive and high IOPS workloads like SAP HANA, NoSQL databases like MongoDB and Cassandra. The other key capability is that a year ago we released Azure Managed Disks. With Azure Managed Disks, we manage all of the storage account creation, all of the scale limits, all of the availability, all of the performance behind the scenes for you to leverage in the cloud. And we offer you 50,000 managed disks per subscription per region. And we'll talk a little bit about managed disk capabilities as well as we go through the session. Some of our key differentiators are we offer an industry-leading 0% AFR. What this means is that we never lose customer data. And how we ensure this is that we create 3 consistent copies of every piece of information that you write to us on our platform before we give you an acknowledgement for your application. So we ensure that your data is durable on our platform. Next, we offer some best-in-class high-performance VMs. With our GS5, you could get up to 80,000 IOPS and 2 gigabytes per second, but on Monday, as we released Ultra SSD, we called out that we're going to release a brand new VM type in the ES series that will be able to get you up to 160,000 IOPS as well. So definitely look forward to that in the coming months. Next, we offered the industry's only single instance SLA for virtual machines that are backed by premium SSD and now Ultra SSD as well. We are the only public platform that offers this. Next, and this is a capability that our ISVs love, is that we offer a unique capability for you to read-write directly to the APIs of what we call as page blobs, which is the underlying technology for Azure Disks. And this is loved by our ISV partners because this allows them to replicate continuously to the Azure platform in a DR or migration scenario where they don't have to actually have the virtual machines running but are able to write directly to our storage, and that way bringing down the total cost of ownership for you for those recovery or DR sites. And this is, again, something that is completely unique to Azure that allows you to write directly to the block storage. Now that you've had an overview, Yuman Liu will take us through what's new on the platform.
Great. So we have talked to a lot of you, and one of the top asks we hear is that we want larger disk sizes. Yes, this is a very common ask for two typical scenarios. One is that you have a data-intensive type of workload. Let's say you run a backup server, file server, and you need tons of storage, but not that much memory and CPU. In that sense, you need a solution where you can scale your storage independent of your compute. Another common use case is for disaster recovery. So for on-premises, you have a machine which is running that you wanted to fail over to Azure. But on Azure, you need a disk that is big enough to store the data on your on-premises drives. Hearing your feedback, we announced larger disk sizes preview support, supporting up to 32 terabytes. It is available in all the existing disk offerings, and this significantly increased the persistent storage you can get on your VM to 8 times as before. Plus, it's also significantly larger than any on-premises SSD and HDD drives you can have. Furthermore, we increased the maximum disk performance target you'll be able to provide. So for existing disk sizes, like for standard disks and standard SSD and standard HDD, the maximum IOPS is raised from 500 to 2,000 for the larger disk sizes, and also bandwidth from 60 Mbps to 500 Mbps, almost 10 times. Then on the premium SSD end, we are offering 20,000 IOPS and also 750 Mbps. Instead of me talking about performance, let me show you performance. So here, I'm on my demo machine. Great. You can see that this is a D32 machine, and then I have attached 32 terabyte disks, which is a premium SSD. What I'm going to do is that I wanted to use IOmeter, which is an open source benchmark tool, to generate some synthetic workload to my large disks. So it depends on your workload. You might be IOPS focused if you're running like online transactional type of workload. Your IO size is small, but you need a lot of IOPS. So here I'm running a test which is IO size as 4 KB. You can see that on a single disk, you're able to hit 20,000 IOPS. That's great. What about, I'm like not very concerned about IOPS. I need to crunch a lot of data. I'm doing big data, Hadoop type of things. So in that case, you wanted to look at a bandwidth perspective. So you have larger IO sizes. In this case, I'm using 256 KB. And you wanted to see how much bandwidth I'll be able to get. You can see that on this you'll be able to push 750 megabytes and even more than that. And these are all writes which goes to your persistent storage, not from the cache. Think of it, your existing workload running on Azure, or the workload you have not yet moved to Azure, with this much higher performance targets we are providing you, there's a lot more capabilities and a lot more opportunities for you to play around with our disk and boost your performance on Azure. So, one second. Sorry, folks. Okay, we're back. As large disk provides scalability increase on both performance and also capacity on our existing disk offerings, in the keynote this week, we introduced Ultra SSD, which is the most performant disk offerings on the cloud. Now I'm going to welcome Michael on the stage to share with you the unique capabilities of Ultra SSD.
Hey, folks. My name is Michael Myra, and I'm responsible for Azure Storage hardware and advanced technology. To understand why we did Ultra SSD, it's advantageous to look back the last couple of years of what we've been seeing as customers work to lift and shift their workloads from on-prem into the cloud. On-prem, customers have access to incredible hardware, whether it's direct attached storage, attached to enterprise servers through serial attached SCSI, whether it's SANs with fiber channel, or the latest flash array technologies that can do hundreds of thousands of IOPS with sub-millisecond latencies as low as 600 microseconds. The customers have access to just a lot of great gear and a lot of great performance. But there's a problem. When they go to the cloud, what they see doesn't match their expectations for what they've been accustomed to on-prem. The virtual cloud disks of the cloud have lower IOPS limits. So therefore, customers have to stripe the disks to get the IOPS they need. And they have to work around the fact that the latencies are higher. When we take a look at the customer workloads, there's two major classes of applications that we see. We have applications that are synchronously designed, such that when an I/O goes out, you don't send the next one until you get an ACK back on it. Examples in this category are like MongoDB, Postgres, and RabbitMQ. In order to get maximum transactions per minute out of these types of workloads, you have to have a disk that has incredibly low latency. On the other side of the fence, we have the big tier 1 workloads. These guys are like SAP HANA, SQL, Oracle, Teradata. These types of platforms can push hundreds of thousands of IOPS with very high throughput because they're very asynchronously designed and can drive a lot of queue depth to the disks underlying it. So we had to do something to really satisfy both of these categories. We decided to hit 4 major capabilities that we were targeting when we came up with Ultra SSD. We needed to achieve sub 1 millisecond latency in order to cater to those low queue depth workloads. We had to have a good capacity range. One of the major feedback we got recently is, maybe you have a transaction log that doesn't need to have high capacity. You want to have a small amount of capacity, but still capable of driving a lot of IOPS. So we went from 4 gigabytes on the low end all the way up to 64 terabytes on the high end for what you can select for a single disk of Ultra SSD. In terms of high throughput and IOPS, we've gone up to the limits of all the VMs that we have today with the biggest VMs we support can handle 2 gigabytes per second, and that's what we can do with a single disk of Ultra SSD. From the IOPS perspective, we've created a new VM type that we'll be introducing into its own public preview in conjunction with the Ultra SSD preview that can do 160,000 IOPS. We needed a disk that was flexible. We wanted to give the customer 3 options to configure their disks independently. We wanted them to be able to select capacity, IOPS, and bandwidth independently so that they can configure a disk that does exactly what they need. A very important aspect of Ultra SSD is it had to be simple. Today, you have to stripe disks, which means you have to have a deployment template or a script that can deploy the VM with an array of disks, and then you have to go into the OS and stripe the disks. But the problem is you can encounter some very sinister types of debug efforts. We were just working with a customer in India last week where we spent a lot of time debugging a problem they had. And the root cause was that we had a set of disks that had caching enabled, but a couple that didn't. And to debug that all the way through took a lot of man-hours of work. But with Ultra SSD, you just pick one disk, and you set it to whatever capabilities you need it to do. And all of that type of complexity is out the window. It's gone. We have very high performance with no caching. We're not using some type of trick. There's no host-side caching at all. Every I/O that you send down to our subsystem is replicated 3 times before it's acknowledged back. And we're getting these capabilities even with writes. All the demos you've seen this week showing 160K IOPS, we're using 4K random writes. So very high performance with no gimmicks. This is a competitive landscape we have today. And as you can see, Ultra SSD is towering over the competition with 160,000 IOPS, with our next best competitor coming in at 60K IOPS. But you got to read the fine print, because Google doing 60K IOPS is only for the reads. They can only achieve 30K with the writes. But with Ultra SSD, you can do 160,000 IOPS with reads or writes. We clock in at 2 gigabytes per second for throughput, which is the saturation point of our biggest VMs. And all across the board here, we have good sub-millisecond latencies. So how did we do it? Ultra SSD was a brand new distributed storage system that we created from the ground up. Rather than taking our existing subsystem and leveraging it, we built it from the ground up because we didn't want to have all of the locking semantics and metadata management that would be required in order to service like a REST API and features like this. This distributed storage system does one thing and one thing really good, which is low latency block storage. The way we set it up is we created for public preview a dedicated compute cluster that is coupled to Ultra SSD scale unit. The purpose of this was to get feedback on our most common VMs. The IaaS family is a good proxy for those big M-series type of VMs. And as we get closer to preview, we're going to start attaching more and more different VM types to our Ultra SSD scale units, with M-series being one of the ones I'm most interested in because SAP HANA is a solution that's one of the main motivators that we went after when we created Ultra SSD. Now, one of the questions I get asked a lot is, are you using NVMe? And the answer is yes. We've been using NVMe for our hardware platforms with this current generation of hardware that we're using now, as well as the last generation of hardware. There's 2 main types of NVMe SSDs out in the market today. One is the U.2 SSD, which is physically identical to SATA SSDs that you're familiar with only difference is the signaling that goes into the connector, which is also the same, is using PCIe rather than SATA. Azure's been using M.2s. We like them because you can cram a lot of them into most of the servers that we have, with the downside of M.2s being that there's thermal challenges because the controller is really near the base of the M.2. So what we did is I came up with something new. We worked with the suppliers to come up with these. This is a SATA, this is an Ultra SSD, ruler SSD. This SSD holds 16 terabytes of NAND and addresses a lot of the issues we've seen with the other types of SSDs. It's very thermally, there's a lot of surface area to take the heat out, and it's hot swappable, and it goes back further into the SSD enclosure. In addition to this, we've also designed what we call an M.2 carrier. So if there's a new type of NAND that's available in M.2s before SSD rulers, we can fall back to this and just use M.2s to solve our NAND needs. Now, the interesting thing about Azure is we open source our hardware. So twice a year, we have an Open Compute Project Summit where we take all of our newest designs and we put them on display. And what you can see here on the right is we have our JBOD, we have an SSD enclosure on top of it, and they're just out for people to see. All of our designs are out on the web for folks to download and use and potentially source out to an ODM for manufacturing. Our current project is called Project Olympus. That's our current platform of technology. This is our SSD enclosure that consumes the ruler SSDs. Each enclosure can handle 16 ruler SSDs, and the best part is it's hot swappable. So what that means to me is that I have lower offline capacity in the data center, but what it means to customers is that instead of taking a whole server down to fix an SSD issue, you can hot swap it, which means there's less capacity going offline and less replication rebuilds being executed in order to deal with the replacement of a single SSD. And here's our schematics for our current server SSD enclosure design. We have a basic 2-node CPU system, and it's just like direct attached storage of the past, but instead of SAS cables, now we're using NVMe so that the SAS cables are driving PCIe signals to PCI switches that fan out to the different SSDs that attach to the enclosure. So a lot of great tech we have going into the underlying platform, and it also supports any of the future technologies that are on our roadmaps in terms of offloads and networking capabilities that might come. We can just bolt those onto that and move forward. Now, what does this mean? One of the coolest things that Ultra SSD can do is 300 IOPS per gigabyte. This is killing the competition. The nearest competitor can do 50 IOPS per gigabyte. And what that means is that when you go down to a really tiny capacity disk, like 4 gigabytes, you can still handle a good amount of IOPS. In this case, you can go up to 1,200 IOPS for a 4 gigabyte SSD. And by the time you ramp up to a 1 terabyte disk, you can already handle the maximum IOPS we support today, which is 160,000. But it's scalable. So if we were to introduce a new VM that can do 320,000 IOPS, you would need no more than a 2 terabyte disk to support that many IOPS. Very capable and very scalable system that drives these disks. We also have a relationship between throughput and IOPS. The high-level story is for every provision IOP, you're going to get 256 KB of throughput. So what that looks like on a graph is that by the time you sweep up to 8,000 IOPS, you can go up to our biggest VM limits of 2 gigabytes per second. Now, you don't have to pick 2 gigabytes per second, but that defines what the maximum allowable setting is. If you don't know what type of workload, what type of IO size you should do, a good best guess would be to start with 16 kilobytes and adjust from there. Now, the pricing is up on the webpage, so you can take a look at it. But there's 2 major points that I want to get across with Ultra SSD. This is not a transaction model, so you're not paying on an IO basis. It's a provision model, which means you set the limits of what your disk can do. And if your IO hits those limits, it gets throttled. This means that you have a very predictable monthly rate. And if you need more, it's very easy to change the IOPS without rebooting the VM to come up with a new monthly cost in order to set up your disks. You'll also see the strange 0.003 vCPU per hour provision reservation. That is only in use if you select that you want an Ultra SSD capable VM, but don't assign a disk. The moment you assign a disk to the VM, that charge drops to 0. The point of it is to ensure that the VM is in close enough proximity to Ultra SSD to hit all of our guarantees for the performance. A quick example of how you would do the math for a monthly charge for Ultra SSD. We took, for an example, a 512 gigabyte SSD with 2,000 IOPS and 8 megabytes per second. And when you do the math, what you wind up here is $84 a month, with the predominantly the costs are coming from the IOPS. Now, the cool thing is, if you detect that you have a cyclical pattern, even on a daily basis, you can script Ultra SSD so that dynamically you can change the IOPS to go high and low. Or if you have SAP HANA churning out financial records, you can turn it down all the way down to like 100 IOPS when you're not using it, and crank it all the way to the max when you're about to do those reports so you can get them done on time. So super flexible, gives you a lot of options for your pricing and how you want to drive your business. For Ultra SSD Preview, we have a sign up. So you go here, You put in your subscription, and we'll whitelist you into the program. It's available in a single zone in East 2 right now, with GA coming up Q1 next year, calendar year, where we are expecting to go to East US, West US, to West Europe, North Europe, and APAC Southeast. Now to talk about some of the other cool features that we have cooking, Yuming is going to come up and talk about how to scale your VM deployments.
Great. Thanks, Michael. As Ultra SSD addresses the scalability for your disk because it provides a lot of capacity, a lot of IOPS, a lot of bandwidth. What if you wanted to scale your VM deployments? Well, you probably say, that's easy. Like if I wanted to scale a 10,000 VM, I'll just create an image and use VM scale sets to scale up. Not a big deal. Let me make the problem harder for you. What if I wanted to scale up 10,000 VMs in 4 different Azure regions? Well, let's say all different Azure regions. How do you plan to deal with the image replication? Our solution for this is Share Image Gallery. So with Share Image Gallery, you'll be able to simply add your image into the gallery, and then you can specify what is the target region that you wanted to replicate it to. Then the platform will take care of it for you. What is even better is that your image in the gallery can be shared across subscriptions. So you no longer need to do the tedious job of copying the same image again and again to the different subscription. I'm pretty sure you have much better things to do. For example, joining us in the party tonight in Universal Studio. So you don't measure with this data movement type of work. Even our internal MSIT team have the same problem, so that we believe with Share Image Gallery, it really helps to alleviate a lot of this management overhead. Planning for scalability is important, but it's not good enough. For any production critical workload, you always need to have a plan B. Just even for my demo, I have a plan B. If it doesn't work, I need to fail over to my recording. If it doesn't work, I have another backup recording in my SharePoint. So for your production workload, you do need a solid plan for disaster recovery. We work closely with a lot of partners and also invest on our native support, Azure Site Recovery, to provide you coverage of the different DR scenarios, starting from on-premises to Azure, other clouds to Azure, and also between Azure regions, from site to site. We partner with a wide range of different backup and DR ISVs. This is to ensure that you can always use your most familiar backup and DR solutions on Azure. This week, Cloud Endure has announced managed disk support for their VM failover for all the 3 scenarios I have mentioned before. Now let's go and take a look at how their failover work. So here I'm on Azure portal. So I have machine 1. This is the source machine. What are we going to do is that we will fail over this machine in West US 2 to a different Azure region. So here, I can see that I have machine 1, and then it's in West US 2 region. I'll take a look of the disks. So the disk is a managed disk. So this is a VM which is using managed disk. I'm going to go to Cloud Endure portal. So I have already set up a project which conducts the disaster recovery to Azure North Central US region. I'll go ahead and select the VM, the machine 1, and then launch the failover job. So I do it in the actual recovery mode. I'll click Next, and then go ahead and select the latest recovery point. So I'll launch the job. Just in a few clicks, you have launched a failover job for an Azure VM using managed disk. Let's fast forward. So 2 minutes later, you can see that my machine 1 has already been failed over. I can achieve an RTO of 2 minutes. I'll go and take a look in the job progress. So in the job progress, it will show a clear trace of when the job started at 10:47 and ended in 10:49 in 2 minutes. So it's a very simple process. I would recommend all of you to actually go back and think, how do you want to plan for your own disaster recovery scenarios? We now have a lot of partners and also ASR supporting DR for VM using managed disks. After sharing with you all these new capabilities on Azure Disks, I would like to welcome Sirius on the stage, where he will go and talk about how is the best way for you to choose the right data storage for your IaaS workload.
Hello, can you hear me?
Yep.
Okay, awesome. Hey folks, my name is Sirius Kutian. I'm a program manager on Azure Storage team. So in the next section, we will talk about how to choose the right disk type for your workloads based on your workload, I/O characteristics, and other requirements. Before we get into that, let's first look at let's look a little bit deeper into the differences between different disk types. We talked about 4 different types of disks. So first, storage infrastructure. When you look at the storage infrastructure, premium SSD, ultra SSD, and standard SSD are all based on SSD as the underlying storage media, whereas standard HDD disks are using hard disk as the storage media. So that brings about a fundamental difference in the latency profile. Hard disks have longer latencies than SSDs, and they also have more variability and more frequent variability in the latency. Whereas SSDs come with much more consistent latencies. As Michael talked about, ultra SSDs come with consistent latencies under a millisecond. Premium SSDs have a couple of milliseconds of average latencies, and for standard SSD, the latency will be a little bit higher than premium, but it's still going to be single-digit millisecond consistently on average. Now let's look at the I/O performance. So here, the key thing to remember is that ultra SSD and premium SSD come with provision performance. So that enables extremely high IOPS for both these types of disks. Ultra SSD can go all the way up to 160,000 today, and as Michael said, it can go even higher if you have a VM that can do more. Whereas for premium SSDs, you can do up to 20,000 IOPS right now. And similarly on the throughput as well. For standard disks, currently, it supports up to 2,000 IOPS and 500 MB per second with large disks. Now that we know that, let's look at how that maps to typical workload scenarios. So this is a generic mapping, general guidelines for mapping different types of workloads into the disk types. So for ultra SSD, your most I/O intensive, largest workloads, most mission critical workloads will map into ultra SSD. That will include the things that you typically run on on-prem SAN arrays and so on. For premium, SSD is the default choice. Most of your production workloads will map into that disk. That will include any enterprise database application, I/O intensive, enterprise workloads that need low latency and consistent performance. Standard SSD, on the other hand, is something we released this week. We consider that as a very cost-effective solution for your production applications that need consistent performance, reliable performance, but don't need high IOPS. It could be things like lightly used enterprise application, web servers, or anything that do need reliable performance but are not I/O intensive. And lastly, on standard HDD, it is still a good low-cost solution for workloads that are not affected by performance variability. Example could be as a backup solution, as mass storage, or maybe dev test. So anything that is not affected by variability in performance. All right. So based on all that information, we built this simple decision tree that will help you figure out what disk type to use for your workload. So this is a rather simplified version of the decision tree. In real life, you may have to consider other aspects also. For example, regional availability, the cost structure, and maybe other things as well. But for now, this is really a good starting point. So it takes into account latency and IOPS requirements and other things. So for walking through this tree and explaining the process, I would like to use some real-life workloads as an example. I think that'll be a fun way to do it. So I would appreciate if you have some volunteers from the folks here, and let's probably start with your largest application. Maybe if you have really large, maybe a database application, enterprise application that needs lots of IOPS, or something like. If you have examples of something like that, please come over here and let's talk about that. Come on over. Let's see if I have a mic. Is it on? Is the mic on? Perfect. Okay, your name is Jim?
My name is Jim. I'm working with a customer. They currently have 120,000 Windows 10 desktops they wish to move to Azure.
Okay.
Fairly storage intensive.
Okay, awesome. So you can hold on to that. What would be the typical I/O intensity for this workload?
So peak I/O for a single desktop is around 2,500 IOPS.
Okay.
Mean I/O is about 20.
Okay.
Yeah, so very high standard deviation.
Okay.
About 80% write.
Okay.
4K block size and 80% random.
Okay, perfect. So in this example, you said you have 2,000 peak IOPS, right?
Per desktop and 120,000 desktops.
Okay. All right, great. And you have each desktop having its own disk. I'm assuming.
Yep.
Great. So here one of the things you need to look at is you would want to normalize it per disk, on a per disk basis or per storage basis, right? All these desktops are not hitting the same disk, right? So in your case, you want to look at having a disk, having a disk for each desktop, and what's the kind of IOPS you need for that desktop, right?
So per desktop is peak 2,000, 4K.
Yeah.
Yeah, 80%
Awesome.
right.
Okay. So in that scenario, here is how we will go about, right? So for that scenario, first thing to look at is I/O intensity, right? For a workload like that, premium disk will be the ideal thing to do for that scenario because it's an I/O intensity. It's relatively high I/O intensity. Standard SSD and standard hard disk are meant for scenarios that need really low IOPS. Something that is, peak would be something in the range of 500 to 1,000 IOPS, and occasional peaks that go into around 2,000 IOPS for really large disks. For typical small disk scenarios, you would want to keep peak around 500 IOPS, and your average IOPS, you mentioned 20 IOPS. That's relatively low. That's good. But based on your peak, you would want to look at the standard disks. And the second thing to look at is that in this, here you have users using this platform, and you want consistent performance for these users, right? So when you look at that, and when you look at the choice between standard hard disk and standard SSD becomes the right choice for very low IOPS scenarios. But in your case, since you need 2,000 IOPS, premium SSD would become the right choice for you. Okay.
So depending on the pricing, couldn't I get Ultra SSD, squash the maximum amount of IOPS and throughput to what I need?
Yeah.
And then what's that going to be in cost comparison? So if I squash Ultra to the same as Premium, and it costs the same, then I'm always going to go for Ultra.
Yeah, absolutely.
Because then I can scale up as and when I need to live, right?
Exactly. So
what's that cost differential?
Sure. So that's another dimension. We haven't put that in the model. Ultra has the unique capabilities not on other disks, which is that you can vary the provision IOPS. You can, let's say you are using the desktop for a few hours a day, let's say.
Yep.
Then you can have high IOPS during that time, and at other times you can keep the IOPS low.
Yeah.
So that aspect needs to be modeled based on your unique usage pattern.
So I've got that data, right?
Exactly.
So is this just REST-based back in the API in the background to control the API?
Yes.
Yeah?
You have API for controlling the provision IOPS. You can call that API to increase IOPS, reduce IOPS, and you can control your provision IOPS based on that.
So do you have any cost modeling tools that we can use to say, okay, I want a very variable IOPS
Yeah,
across the day? Or
Michael had the high-level pricing, preview pricing he talked about today. So you can take that price. It's published in our pricing page, right? You can take the price. It's pricing it shown as per hour, right? So you can see.
You could say, go away, do the work yourself. That's fine.
No, it's fine. It's fine. It depends entirely on the duration, right? So based on that, you can calculate the price. And because for Ultra SSD, the price really depends on your capacity, depends on the exact IOPS, depends on the throughput you need, right? So Ultra SSD gives you that flexibility. So that also means is that your exact price you need will depend on that exact configuration, how long you need it and how much.
Yep.
So you have to really look at that total and go from there.
Thank you.
Okay. So any other volunteers to talk about maybe a really large database? So let me talk about another example. I heard it from someone I talked to the other day. So they had a LOB application used by around 20 to 30 users. It's an important application. They want to have consistent performance for that application, but it's used by just around 20 to 30 users, not heavily I/O intensive. Occasionally, they have some batch jobs that need 200 to 500 IOPS. So that's the kind of system they use, and they would like to have a really good experience for the users, and they want to have a cost-effective solution as well. So for that thing, for something like that, the ideal option will be, since it's not I/O intensive, they could use the standard disk as a solution, and since they need consistent performance, standard SSD becomes a good cost-effective solution for that. So we will publish more details of this model in our documentation, and hopefully it'll help you pick the right disk type for your workloads. So let me go to, so next I want to talk about a couple of best practices that will really help improve the performance of your IaaS workloads. One is monitoring. So we talked about the I/O patterns for your workloads and how that affects your configuration choices. So sometimes you may not really know the workload requirements beforehand, and sometimes it can vary, it can change over time as well. So it's important to keep an eye on how it's trending. The good news is that we've recently added per disk metrics for your managed disks. You can also set up alerts for those metrics, alerts for your stats, and take action when things are approaching some limits. So we have more demo on that, and I will ask Yumin to come over here and talk about that. Okay. I'll stay here, I think.
Yep. Thanks, Iris. So for monitoring and alerting, so previously we have always had disk throughput on both IOPS and bandwidth, but that is on the VM level. So we hear feedback from you as, that's not really helpful, because if I have multiple disks, what am I going to do with it? For the example Michael just mentioned, like you have inconsistent configurations for different disks. So when I only look at the all-up VM IOPS, VM disk IOPS and throughput, it's not able to help me diagnose the specific problem. Knowing that, we added per disk metrics. So here, let me switch to my demo machine. Now I'm on Azure Portal. I have selected the VM that I've just did the large disk demo. I hope you still remember that. So I'm going down to metrics. Let's actually think of a real problem so that we can go through the metrics. Assume that I'm running a backup server. So for a backup server, what is most important? My backup drops complete in time, right? So for a backup type of workload, what you're mainly doing is a lot of writes to the persistent disk. Then I'll think, what should I look at? Disk write bandwidth. I think that is something which I should pay attention to. So now let's take a look of that. I'll be able to go and select the data disk write bytes per second, which is basically the bandwidth. And I wanted to look at my maximum case, like at my peak state. This will help me to know that for this disk that I'm using, is the provisioned throughput enough to actually sustain the traffic from my application. So I'm going down to max, and then we will split it based on the long. So the long ID is when you specify, when you're trying to attach a disk to a VM, you need to specify the long ID. You can use it to actually identify which data disk you're using. So in the matrix now, I can see that, okay, as what I thought, my write bandwidth is very, very high. So it's already exceeding the 750 Mbps, which is on this provision disk, is now at 760. Okay, yeah, I should probably keep an eye on my bandwidth. What about IOP? I think my IOP should be okay since I'm doing very large I/O sizes. But let's take a look. So we'll go to data disk write operations per second. Also look at the. Also, I'll go and look at the maximum, and then split it based on the long ID. So right now on my VM, because I only have one 32 terabyte disk attached, so you only show one disk at long ID as 1. So if I look at the point which I have very high bandwidth, my IOPS is at 3,000. So it's as I expected because I'm pushing very large I/O size. So IOP might not be something I need to, be very concerned of. One other aspect we will recommend you to take a look on is the queue depth. So queue depth is a point in time status of what is your outstanding IOs. So to help you understand, you can also think it as how many threads do I have pushing my disk traffic. This is one of the indicators you can use to see how much parallelism you have when you're pushing your disk traffic. So for our larger disk sizes, we provide very high provisioned throughput. So in this case, you do need higher queue depth to be able to get the full power of the disk. So here, let me take a look. For my data disk queue depth, look at the maximum case. When I hit the number, I'm doing 250. That's very high. So I'll be like, okay, I think that is roughly what my application will be pushing. So this is a good representation of my peak use states. One thing we always recommend you to look at is to compare the set of metrics reported on Azure resources to what you have on your application. In many cases, we see problem lays where you have inconsistency when your disk traffic are sending down due to alignment and file system type of issues. You actually have throttle points while your disks are actually sending down to Azure resources. So it's always a good practice to cross-check. So for this current example, you can see that at my peak traffic state, my disk throughput is exceeding the 750 megabytes per second provisioned bandwidth on this disk. So, should I take an action? Do I need to add more disk? Should I upgrade to Ultra SSD? We will suggest you to take a data-driven approach. This is in the sense that you should look at the period, let's say 7 days, 1 month. How often does my disk bandwidth exceed the target provision target? One of the best way of doing it is to use Azure Alerts. Why is that? Because you don't need to actually manually go and look at it. You can specify what is the criteria that you want the alert to be triggered based on the Azure matrix. And then it will notify based on how your preferred notification channel. So here you can see that this is on the alert summary page. I have configured 2 types of alerts on this disk. One on the provision IOPS, another one on the provision bandwidth. I have a few alerts getting fired. So we can zoom down and see into one of the alerts. Okay, let's pick the first one. In the detail session, you will be able to see exactly what is the criteria that you have set for this alert. In this case, it's saying per disk write bandwidth. And when would the alert get triggered? 750 Mbps. And it also shows when the alert got fired, how much disk throughput is my disk actually achieving. It is at 760 Mbps. So what this helps you is that Azure will be able to monitor your resources and trigger alerts whenever it exceeds the criteria, exceed the threshold you have specified. What is even better is that we support a lot of different type of notification method, including SMS, email. Even better, we can integrate with Azure Function. So if for your production critical workloads, you will be able to automate the mitigation steps when your disk or your other resources throughput actually hits certain thresholds. We can trigger the mitigation step automatically. Whenever the alerts get fired, you'll actually go ahead and execute the mitigation steps you have automated in Azure Function. With Azure Metrics and also alerting, we recommend you to actually take a look and see how you'll be able to use these tool sets to help you choose the most appropriate disk offerings and also find the right configurations for your workload. Now I'll hand it over back to Sirius.
Okay, awesome. Thanks, Yumin. All right, so we are done with the demo. So next thing I want to hit for the VM performance is the host caching. So some of you may know the Azure VMs that support premium disks come with an advanced caching technology called Azure Blob Cache. So this will really help you improve the performance of your virtual machines by using the local SSD on the compute host. Using caching, you can get extremely low latency for cache operations and even more IOPS using the cache operations. So there are different settings based on your workload. For OS disks, you will see that a default setting is read-write caching. For most other workloads, typically a mix of read-write workloads or read-heavy workloads, recommended cache setting is read-only. That gives you the best performance. For write-heavy workloads or write-only workloads, such as the log disk for databases, we would recommend keeping the caching turned off. That's caching none for the best performance. There's a read-write option also available to you, but it's a little bit of a risky option because the writes are cached, and if your application doesn't handle the persisting, flushing of it, you could lose data if there is a problem with the hardware. So you have to use that more carefully. But if the application is doing it correctly, you can really get a good performance using read-write caching as well. All right, let's move on from there. All right, so we talked about disks as the storage for your virtual machine. We talked about different types of disks. So I do want to also call out here that aside from disks, you also have a couple of other options for using the storage for your virtual machines. And those are page blobs and file shares. So page blobs are a type of objects in Azure Storage that are optimized for fast, random read-write operations. And you can access them through REST APIs. I'll talk a little bit more about that in the next slide. File shares or Azure files shares are fully managed file shares in the cloud. We support SMB protocol. It makes it very easy to mount on your virtual machines and use that storage. So if you are interested in file shares, we have a detailed session in the afternoon. I encourage you to attend that session to learn more about file shares. So a few more points on page blobs. There are mainly two use cases when it comes to using page blobs for IaaS workloads. One is shared storage. So what that means is that you can have multiple virtual machines using a page blob or a pool of page blobs as a shared storage for the virtual machines. You can handle. There are storage features for handling the concurrency of your clients, using leasing, using LMT, sequence number. There's a whole bunch of tools and documentation available for handling the concurrency. So using all that, you can really expand the storage available to your VMs independent of your virtual machine itself. And the next thing I want to talk about is the custom drivers. Another way you could use page blobs is that you can build a custom driver that implements your technology to access page blobs, and then you can use the driver, install the driver on the virtual machines, and then the workload can access the page blobs through that driver. An example of that is there's an open source driver for mounting page blobs as a disk for Linux containers. That makes it really easy to have tons of containers on the VMs. Another example of a solution using page blobs is FX Logics. That's a company we met with them last year at Ignite, and we worked with them thereafter to figure out the right solution to bring their technology to Azure using page blobs. I have Randy Cook from FX Logics here to talk more about their technology. Randy.
Thank you. Thank you, Sirius. Good morning. Mic on? There we go. Good morning. We're glad to be here talking about our solutions that we're building on top of this great technology that Microsoft's providing. Just a quick overview about our company. We provide a bunch of solutions just to make your virtual desktops, Citrix environments, VDI environments run really well. And I'll give you a quick overview of those. And we're announcing this week direct support for Azure Page Blobs, and I'll be demoing that here in a bit. Just a quick overview of our app portfolio. We have application masking, which is a solution that lets you control applications per user, even on multi-user systems. It works different than application virtualization in that it just hides completely applications from users so they don't get access to them, but it's the native installed applications. We do a similar thing for Java applications and websites. If you've got old versions of applications that require previous versions of Java, you can specify what versions of Java those run with and let you run all of your other stuff with the latest version of Java. Our hottest product that we've got going right now is our Office 365 container. Office 365 is white hot in the market right now, and the magic that we do, which makes your Office applications run at native speed in these roaming and non-persistent environments, is really desirable. So we also do a very similar thing, but we can contain your whole entire user profile and make that fast for you as well. All right, so today we're talking specifically about our Office 365 container and profile container products. Those are the ones that specifically use our new feature, our Cloud Cache feature, and that is what's supporting the Azure Page Blobs. So we're going to actually do a demo here for you. And just a quick idea about what's going on here. We've got a client computer that's got the test user 2 that's about to log in there. We have the Azure Storage Explorer on the right-hand side. And then down here at the bottom, we actually have an SMB server, just a regular Windows file server. We're going to go ahead and log this user in. And what you'll see is immediately the user profile is now being created. And you'll see that it goes to both upstreams. So we're sending that data both to the local file share and to Azure Storage Page Blob. And you'll see why we're doing this in a second, why we're doing the 2 locations. All right, while that profile is building, I'll talk a little bit about the architecture of our solution. We have an agent that gets installed into the local Windows image, and this can be any Windows image. There's no hypervisor dependence or anything like that, so it can be installed anywhere that Windows runs. And it's doing a lot of the block level I/O. We're intercepting that, and we're controlling where that's going to and where it's being read from. We're able to take advantage of the local storage, which means that in addition to RAM caching, we can do local disk caching, and we can greatly reduce the amount of I/O that goes over your network in support of these VHDs. What we're announcing this week is that we can actually have as an upstream an Azure Page Blob, and this, of course, is accessed directly through the REST APIs. There's no SMB gateway, nothing like that. And there's a bunch of advantages that we get with that. We'll talk about those in a minute. Kind of our legacy support is that we support regular file servers. And you can tell here that we can support one or more multiple upstreams where this data is pushed and stored. All right, so some of the advantages here. We push the whole profile to Azure, not just bits and pieces of it. If you had everything go away, you can completely recreate the user profile with what's in Azure. We have the redundant storage, which I talked about, which means that if one of your locations goes down, user is uninterrupted, and we'll give you a demo of that here in a second. The other thing that's really interesting here is that you have a good migration story, too. So you can start out using your on-prem file server for your profile storage. As you start to think about moving to Azure, you just add that into the configuration. Our agent starts pushing that to both locations. At some point, you can actually switch over where the Azure becomes the primary read path. And then if you want to later, you can actually remove your on-prem file server. All right, so coming back to the demo now, we see that the client is actually fully logged in at this point. All of the profile bits are pushed in real time, of course, to both upstreams, Azure Page Blob and local file server. And we're going to go ahead and create an Outlook profile for this user. This is first time logon for this user. So what's happening here is that Outlook is being configured. With our solution, you can actually turn on local OST caching. And that's what makes Outlook and some of the other Office applications run at native speed, is because you turn on all the local caching. That's going into a VHD, and that's connected locally. You get really good performance. Outlook will start up here, and you'll see pretty quickly here that the emails start popping in. And what we're going to do now is we're going to come down to the file server VM, and we're just going to shut it down. We're going to simulate a catastrophic outage where the file server becomes unreachable, and we'll see what happens to the user experience in the client VM. So here, literally, we could do anything. We could disconnect the network. We could just power off the VM. We're just going to shut it down. So at this point, the client was pushing and reading from the SMB server. Now notice that that's gone away, and it's failed over to Azure Cloud. And the user experience is completely uninterrupted. The user has no idea this has happened. And now what happens when all those writes are happening that would normally go to the SMB server, they're cached on the local machine. As soon as that SMB is restored, all of those writes are now pushed up to the SMB, and it becomes up to date with all of the latest stuff. All right, so just a quick refresher here as we're covering this. We're using the REST API, which is just a beautiful thing. It's super firewall friendly. It's going over port 443. Just regular HTTPS traffic, and there is no server gateway, SMB gateway required, so it's really fast, and there's no additional cost there. We support various tiers. We're demoing here on premium storage, but we support other tiers as well of Azure Page Blobs. And as we showed here, you can use any combination that you want. You can use one or more, as many upstreams as you like. If you'd like to see this in real time, we're happy to have you come by our booth. We got a good kick out of this. Our booth number is 443, not on purpose. So very coincidental there. We had a good laugh out of that. So with that, thank you, and I'll turn it back over to Yuman.
Yes, thanks, Randy, for giving us a real example of how you can leverage the unique capabilities of Page Blob. So, we would like to now unveil our product roadmap of Azure Disk for 2019. See, the last one stays. Actually, here the best stuff. So, for us, we will continue to actually improve on our user experience on managed disk, making it easier to use, faster, and also more secure. Share image gallery, one of the good examples, help you to remove the management overhead on images. If you're considering of consolidating your resources, moving managed disks across subscriptions and resource group is now supported in preview, and we do expect to GA it soon. Incremental snapshot, this is one of the top asks as well. This is critical for providing a cost-effective backup and DR solution. We share your priority here. We are working full horsepower to deliver this by end of this year. On the security front, we will provide storage-side encryption with customer-managed keys. This will allow you to protect your data with your own key. To help you further better adopt managed disk, we'll make enhancements on the data importing scenarios, where when you're trying to import your data either from other clouds or on-premises into managed disk. We will remove the dependency of storage account and still provide you a secure way to import your data into managed disk. You actually see that a lot of our recent announcements are related to scalability, performance. This is because we know that you are expanding your footprint on Azure, and you are moving your last piece of most critical workloads from on-premises to Azure. And you do have a very high expectation on both performance and scalability. So we are not going to stop where we are. With large disk, we will GA and provide full feature support with integration of Azure Backup and ASR. Ultra SSD, the buzzword of Ignite, we will bring it to more regions, making it accessible for your global customers and take advantage of this latest technology. Lastly, Premium SSD, our most popular disk offering used for production workload. We will further drive down the latency to 1 millisecond so that it's able to satisfy the latency requirements of your majority enterprise workloads. With our latest release and our plan for 2019, we provide the most comprehensive and performant disk portfolio, and it's supportable for all of your every workload. Thanks, everyone, for attending our session. Your feedback is very important to us. Please take some time to evaluate this session. So our team will be here, and we have An and Kay, who are colleagues from the Disk team, who will also be here to answer your questions. So I'll open the floor for Q&A. We'll also stay around a bit so we can also address questions off the stage.